Hello students. Within the last session, we have discussed distance time graph for uniform motion and non-uniform motion. For uniform motion, this graph is a straight line, and for non-uniform motion, this graph is curved one. Then we have discussed that is uniform velocity. So the graph of velocity time for uniform velocity. And then we have discussed the graph of velocity and time for accelerated motion or uniform accelerated motion. That means acceleration is same. Now with the help of these graphs, we are discussing the new point, that is equations of motion using the graphical method. Suppose any object is moving with an initial velocity, that is first velocity, when we are going to measure the velocity, that is u. V is a final velocity, and from initial velocity to reach the final velocity, the object has taken the time t. A is acceleration, that means v minus u upon t, that is acceleration, and s is a displacement, that means the distance travelled by the object if it is linear motion. Then Newton is giving three equations. These equations have given by Newton. He has discussed the relations between velocity, both are velocity, initial and final velocity, second is time, then acceleration and displacement. With the help of these four entities, which are the velocity, time, acceleration and displacement, Newton has stated three laws which are related to motion. Which are they? Number one, V is equal to u plus at. That means velocity, final velocity is equal to initial velocity plus acceleration into time. So this one is a velocity, this is also velocity. N is acceleration, that is change in velocity, a rate of change of velocity. So both these three indicating velocity, and t is time. So this equation is representing relation between velocity time relation. Okay, see what is s? S is the displacement, u is initial velocity, here we having time plus 1/2 of at. So within this equation here we having displacement on one hand and velocity on the other hand. See, this one is a displacement ut, that is initial velocity into time and half of acceleration into time. So one side we having displacement and second side they have given importance to time. So this is called as displacement time relation. Displacement time relation, this is the equation. Now the third equation, we having here v square. V square means what? Velocity, final velocity square is equal to initial velocity plus acceleration into displacement. So this one is the velocity, this is also velocity, this one is a change in velocity, and now we are having the displacement. So the third equation represents the relation between velocity and displacement. So see, what are there? Velocity, time and displacement. Velocity time, first equation, displacement time, second equation, and velocity displacement, the third equation showing the relation. Out of this we are going to discuss the first, how he has derived. See, first of all, one point, object starts from point D with the initial velocity u. Suppose one car or any object is traveling on a straight line. When you are going to start the measure the velocity, that is the initial velocity, we are going to represent by u. Then speed is increasing, that means velocity is increasing. By increasing the velocity, the object reaches after time t at velocity v, that is the final velocity. So first when object started to move, it was at point D. So velocity on y-axis we are representing velocity, on x-axis we are representing time. As time increases, definitely velocity also increasing. Uniform velocity we have in here. So here, as velocity increases, we having the velocity time relation, because of that is uniformly accelerated motion we having. So straight line we are getting. The graph is straight line. So because of straight line, when object initially was at D point and now it is at B point. When the object was at D point, initial velocity was u. So O to D, that is initial velocity having. Now when object reaches at point B, its velocity is v, that is final velocity, and final velocity is c to O, that is the distance we having. OC is the final velocity, and from u to v, that is velocity of u to reach the velocity of v, it has taken this much time, that is t. So OE is a time. So what is OD? OD is initial velocity. Then OC, it is a final velocity, and OE is a time taken to reach that final velocity. So how to start? Object starts at point D with initial velocity d. Then its velocity is increasing. As time increases, velocity also increases. After time t, it reaches point B, and when the object is at point B, its velocity is v, that is final velocity. So OD, that is u, is the initial velocity. OC, that is v, is the final velocity, and OE is equal to t, that is the time taken to reach that one velocity. So what is acceleration? So we know the well-known formula of acceleration: change in velocity divided by time, rate of change of velocity. So change of velocity means what? Final velocity minus initial velocity. So what is final velocity here? OC is the final velocity and OD is the initial velocity. Getting? So suppose OC minus OD. So what we are getting? Here we are getting CD. Is it clear? OC minus OD. OC minus OD. So remaining part is CD. So acceleration is equal to CD divided by time as per this relation. Now if you multiply t towards A, then CD is equal to AT. That is the first equation. Now what we have done? We are going to draw one parallel line which is parallel to y-axis from point B on x-axis. So this is the parallel line. So here we are getting the 90 degree. And again from D, we are going to draw one parallel line to that x-axis. So here we are going to get one triangle. Which one? Triangle we are getting. But see here, it is a straight line or not. So in between point B and E, there is a point A. So how we can calculate this one? B is equal to AB plus AC. AB plus AE. What is here? AB plus AE. BE is equal to AB plus AE. But see here, what distance we having of AB? That distance is of CD. So can we consider this one CD? And here distance of AE, which is a parallel line, and so distance in between parallel is always same. So AE is equal to OD. So what is B? B means what? Final velocity. So this equation we are getting. Now tell me what is BE? BE. BE is nothing but OV. What is here? BE is nothing but OD. OC. So shall we consider here OC? So OC is equal to CD is equal to OD. That equation we are getting. But OC is equal to V. Okay, what is CD? CD, here equation 1, CD is equal to AT. And what is OD? OD is equal to U plus U. So finally we are reaching B is equal to U plus AT. That is the first equation stated by the Newton we have got. After discussing the first relation, that is velocity time relation, we are focusing on the second relation, that is displacement time relation. So what is the equation stated by the Newton? Displacement is equal to ut, means initial velocity into time, plus half of acceleration into time square. See here. So are you observing or are you revising this one or memorizing this one? Within the last session we have discussed displacement, that is distance travelled by the train. What kind of quadrilateral was forming there? That quadrilateral's area is equal to the displacement of that train. So here is also one quadrilateral is forming. Which one? See here, O, D, B, E. This is the quadrilateral. So here displacement S is nothing but what? Area of quadrilateral. Which one? O, D, B, E. O, D, B and E. Okay, see. But this quadrilateral has combined because of this is the first part and this is the second part. First part is a rectangle. So that is equal to area of quadrilateral. Which one? O, D, B, E. O, D, B, E. Plus area of triangle we are having, that is D, A, B. This is the triangle. So we know these formulas. Which are they? Within the first one, what is the formula? Length into breadth. So what is length? OE is the length. OE into breadth is OD plus half of base into height. What is base? AD. AD is a base into height. What is the height here? AB is height. Is it clear? Now I am changing little things here. See, OE. What is OE? OE is a T. So OE is T into what is OD? OD is nothing but initial velocity plus half of, see, AD. So what is AD? That is OE. So OE is equal to AD is equal to BC. OE, AD and BC are same, and that is the time. Into AB. AB means what? Here CD. AB and CD equal. So AB is equal to CD is equal to 80. So here we are having 80. So what is the final formula? Here we have displacement is equal to UT plus half of AT into T, T square. So displacement is equal to UT plus half of AT square. This is the second formula we are getting, which shows the relation between displacement and time. The third relation. What is the relation? Velocity displacement relation. So what is that equation? B square is equal to U square plus 2AS. That is the relation given by the Newton. But how it is, that we are discussing. See here. Here we are having displacement. Just before this, what we have discussed, displacement is equal to area of this quadrilateral. If you consider, say, OD, OD I have given here. UB, that is DB, I have written here. Then ABE, BE is here, and OE. So just one trapezium has formed, in which we having BE is parallel to OD. These two sides are parallel, and this one is a height, and OE is equal to height we having. So what is the distance of OD? OD's distance is U, initial velocity. BE, BE means OC, OC and BE are same. See here, OC and BE are same, and that is V. Where we having here OC and BE is equal to V. Then OE is equal to T, that is the time. OE is equal to T. So displacement is equal to area of this trapezium. So here. So what is the formula of trapezium? Trapezium formula is half into sum of length of parallel sides of trapezium into height. So see here, 1/2 into sum of length of parallel side. Parallel side, that is OD plus BE into height is OE. So half of OD is equal to V plus B is equal, OD is equal to U, B is equal to V into O is time T. But we know the time T. So come here. So what is acceleration? Acceleration is equal to V minus U divided by T. So if you want the value of T, alternando, T is equal to V minus U divided by A. So here in second formula here, 1/2 into U plus V into or divided by 1, or T is equal to, that is V minus U divided by T. So U plus V, though it is U plus V, shall we convert like this one? V plus U, that is 2 plus 3, 5, and 3 plus 2 also 5. So nothing to worry. So here we are having A, acceleration. If you do the multiplication of numerator and denominator, we are getting V plus U into second bracket V minus U divided by 2A. So as we are getting this one, here cross multiplication, 2AS is equal to, see here, identity, A plus B into first bracket, A minus B into second bracket, A square minus B square. So here V square minus U square. So you want V square, so U square should be transferred this side for plus. So V square is equal to U square plus 2AS. That is the final equation we are getting. That is the third relation given by Newton, that is velocity displacement relation. So these are the three formulas or three equations stated by the Newton within that session we have discussed. Thank you.